So experiment. Okay, so first of all, we forgot to make out our table beforehand, so let's remind ourselves what we would do. Okay, so you'll have current, the current you're measuring. Okay, we'll be going from 0 up to 4 amps here. Okay, once we have the current, we'll be able to get the current squared. Okay, and that will be your x-axis afterwards. That's the rock spot. Okay, we get the temperature before we add the energy to the water, and the final temperature after, and from that we'll get the change in temperature, and that will be the y-axis change in temperature. So we'll have a graph of delta theta against I squared, and we expect to get a straight line graph through the origin. Okay, so the apparatus, right, as before. Okay, we have our, so we can see it. Okay, so we have our power supply, and as always connected to both ends of our variable resistor, and then going from there, let's make sure we're clear on it. Okay, we're going to an ammeter. Okay, and from the ammeter, we are going to the coil. Okay, and the coil, then we're going back to here. Okay, to complete the circuit. So the red is the main circuit, the blue is the potential divider giving us a varying voltage, which in this case gives us a varying current. Okay, now we're going to add water. Okay, so what you will be doing, okay, I'm going to do this once. Okay, I'm going to do one value, and I'll give you the other values then later. Okay, so in this case, I'm giving you, we're going to add 60 milliliters, which is 60 grams of water. I'm using a graduated cylinder for it. I could use balance as well. But when you're doing this in September, okay, you'll be getting 6 of these ready at the beginning, all with the same mass, and it's easier to use volumes rather than masses. You'll get 60 milliliters, which is 60 grams of water in 6 different cups, and you'll be repeating the experiment 6 times, because remember, we want the temperature to be the same at the beginning each time. So I'm going to measure the temperature here. Okay, so just putting in the thermometer in, measure the temperature. You'll have trouble seeing that now. Okay, so I'm going to call that out to you. So that is a temperature of 19 degrees Celsius. 19 degrees Celsius. Okay, right. Now, okay, next step is we want to do this for 3 minutes. Okay, so I need a watch. A watch. Okay. But we manage. Okay, so we're going to turn this on. Okay, 19 degrees. Put this in. Okay, make sure the coil is covering is covered by the water, which in this case it is. Okay, we turn this on here. Okay, we turn on our ammeter and wait for things to get ready, and we want to get this current. So I'm looking to get the current here to, let's say, 3 amps. Okay, so we've got the 2. Okay, so 2 amps, current's at 2 amps. I've started my watch now, and I'm going to wait for 3 minutes. I'm pausing this. Okay, so I've unpaused. We're just coming up to the 3 minutes, so I'm going to turn off the current. Okay, and I'm going to give this a good mix now to get the final highest temperature. And the final highest temperature in this case is 25 degrees. Okay, so it's gone to 25. So this was for 2 amps, so I've down here gone to 25. 2 squared is 4.0. It's gone to 25, so the change in temperature there is 6. Okay, so I've done the experiment for the other values. Okay, and I'll give you the initial temperature the same in each case, because I started with different water each time with the same mass, and these are the final temperatures in each case. So you'll need to find the change in temperature in each case, and you need to find the I squared in each case. I've given you another example here. and then you're drawing a graph of delta theta against I squared. We're not worried about anything except verifying the law. So you're not worried about the time and the mass down here. They will be only to do with calculations afterwards. We're not interested in that. We're interested in seeing how this verifies the law. You expect it to be a straight line graph through the origin, and then you will say delta theta proportional to I squared. Okay.